All right, this is worksheet 1B, and this is the second day. We're going to do a little work in chapter 8. We're going to revisit a couple graphing situations towards the end of the period, but at the beginning we're going to mostly talk about equation solving and reviewing some TRIG trades. So these first few questions are just TRIG trade questions. How about if you do the first three on your own, and I'll call on a couple people in a minute. See if you can figure out what those first three should simplify to. Anyone tell me what they did on the first one and explain it as you went? What did you trade out? Right, secant is just 1 over cosine, so why is it paused? Oh, it's frozen up there, that's all. It's not paused on my computer. Okay. Cosine times 1 over cosine, so Elijah, what'd you get? 1. Anybody have an answer for number 2? What did you do? Okay. Okay. Or cosine, cotangent was just cosine over sine. That's all right. It worked. Number 3, did you have to do a lot of thinking about this one? What's the reciprocal of secant?
Oh, all I do is reciprocal.
All right. And I forgot. I don't have number 4 on here. Can someone read number 4 for me? All right. I don't know why I'm missing that one, but any ideas? What? If we take a cosine out of the top, what will we have left? And then we can cancel those. So we're left with a 1 minus cosine squared, which is sine squared theta. Okay? Was it a proof or on yours or just to simplify? Okay, so sine squared is what it simplified down to. Number 5 is also just to simplify. Anybody think they know what we should do with the top? You want to turn cotangent into cosine over sine? Anything else? Okay. I wasn't sure if you wanted me to change that one too, but yes. First thing I would have done was trade all that for a 1. Okay, so we have 1 plus cosine squared over sine squared. And that is being divided by a 1 over sine, which means it's being multiplied by, okay? Yeah. This is actually a trade, guys. What is this? 1 plus cosine squared, or 1, what is this? That's a cotangent, right? A cosine squared over a sine squared? Yeah, we did this the long hard way. Right here, this was 1, and 1 plus a cotangent squared is a And a cosecant squared over a cosecant is, I'm thinking I should have been able to get there down here if I did this mess. If I distributed this, I would have had sine x plus cosine squared x over a sine x. Then I would have had to get a common denominator. And then this would have been 1 over sine x, which is cosecant x. So the long, painful way we were working at it here definitely works. It's just much shorter this way. Ooh, sorry. All right. This is new stuff. Everybody awake? Okay. Can you look at your TRIG trade sheet? And there's a part in the middle of the identities section that says odd relations. Okay. Now this is not talking about crazy Uncle Joe. He might be odd, but we're talking about odd and even relations. Get it? Odd relations, yeah. I have some very odd relatives. I don't know about you, but. All right. Even. Which functions are even, guys? Okay. Cosine and its reciprocal because they have y-axis symmetry. And the idea is if I go to the right a certain amount or the left a certain amount, I'll get the same answer. So therefore, when you have an even function, going to the left or putting a negative in here doesn't matter. You get the same answer as if you didn't. So we say we can drop the negative for an even function. Okay? For an odd function, like sine or tangent or cosecant or cotangent, when you go a certain amount to the right and get an answer, you would go that same amount to the left and take the opposite before you'd get the answers, what it amounts to. So we need to say I'm going to take the opposite. When it's odd, the negative comes out in front. So here, move your negative out front is for when you have an odd function. And those are clearly stated on here. Does everybody see that on their identity sheet? It says for sine, you move it out front. For tangent, you move it out front. For cosine, you get rid of it. Everybody see what I'm talking about on here? No? Yes?
No, I got it.
Okay. All right. So let's fly through these real fast. What is going to happen for sine of negative 2x? The sine is going to come out front. Okay. For number 7, what's going to happen to cosine? It is even, so it's just going to drop. And secant? It also is going to drop. And we could rewrite that, or we could just say, I know in my head that cosine and secant are what? Reciprocals. So when we multiply, we get 1. Everybody okay with that? Or you need me to write cosine times 1 over cosine? All right. Cosecant, what did we say? Even or odd? It's related to sine, and sine is odd. So cosecant is odd, and odd means we do what? Okay, we move it out front. Tangent? What do you think? What should number 9 be? Negative tangent of 3x. Okay, let's do top and bottom separately here. What about sine? Okay. And cosine? The cosine of the opposite of x is the same as the cosine of x. So sine over cosine would be tangent, and we have a negative, yep. Does that seem okay? All right, so that was kind of new stuff. Eventually, on some of the equation solving, we might have to do a little bit of that. All right, the next section we did yesterday, right?
Yeah.
This one was no. Oh, we graphed this. I didn't put a copy of the picture, but this one turned out to be yes. I do remember it. We went over it with the bold, right? This is the picture, and it turned out to be no, despite the fact that we kind of thought it was going to be yes, right? It has to do with the fact that a square root only has positive solutions. All right, 14 is your basic equation solving. Are we going to graph on our calculator or use our unit circle? Yep, we can use our unit circle to find where the cosine is 1/2. Where's the cosine 1/2 here, guys? And 5 pi over 3. We can write that, or we can do a little bit of a shortcut. We could go 60 this way or 60 this way. So that would be a positive pi over 3 or a negative pi over 3 if we wanted to write that. It says all values, and we're going to go with unit circle unless it happens to say degrees. Did I get that right, guys? It's pi over 3 and 5 pi over 3, right? Okay. The longer version would be to write it like that. Does anybody remember what we did yesterday? We had one with either cosecant or secant yesterday. If I write cosecant is 1 over sine, and this side would just be negative 2 over 1, right? Now, I flipped them both over, but I want to talk about why that's okay. If you have 4/2 is equal to, I don't know, 10/5, are those equal, guys? They're both equal to 2. Is it true if I flip them over, are they still equal? Okay, so it's all right to just flip them both over as long as you do it to both of them. So this would become sine x over 1 equals 1 over negative 2, which would be negative 1/2. So where is the sine negative 1/2? Okay, everybody find them? There are other ways to write that, but none are any shorter. I mean, you could have called it negative pi over 6 and negative 5 pi over 6 or something, but it doesn't matter. It's still the same number of answers.
What is usually the answer? What
Say that again.
value for
Where we should really be writing where n equals any integer. Has to be a whole number. So where n could be 1 time you're going to go around, 2 times, 3 times, negative 1 times. Okay? All right, what about 16? First step, anybody? Divide by 3. Now, tangent is the one that's a little bit tricky. And this one is particularly tricky. I always think of this as before this was rationalized, it used to be 1 over the square root of 3. Does everybody see that? 1 over the square root of 3 would have become square root of 3 over 3. And either the top or the bottom is negative. So I am looking for ordered pairs. Remember, tangent is y over x, so I can have negative 1 and a square root of 3 here, or I could have a positive 1 and a negative square root of 3 here. Are those some unit or some ordered pairs on our unit circle?
Yes.
Okay, and where do they occur? I don't know. I'm trusting them. I'm going to look here. We need the 1/2 to be at the back. So it's here and here. And what do you notice about those two, guys? They're straight across from each other because the period for tangent is what? Pi. So I would have just written one of them plus or minus pi n. If you wrote both of them and put plus or minus 2 pi n on the back, I would not count it wrong, but you would need both in that case. Is that the end of that one? Okay. We have some more of this same kind of fun on worksheet 2. Now, worksheet 2, side A, we actually did this side in chapter 7. It would really be good practice for some of you to go back over this side, but you have it in 7. I don't know which worksheet number it was in chapter 7, but if you still have your chapter 7 notes, we did that one. You don't have to do 2A. But I'm going to go down to, is this side B? This is worksheet 2, side B. All right, who thinks they have this one? Anybody want to come up and write it? Go ahead, Sean. Do it on your paper, guys. See if you can show a clear sequence of steps to show that this is true. That's okay. Okay. Thank you. All right, guys. Sean traded 1 minus cosine squared for a sine squared, cosecant for a 1 over sine, and then canceled one of the sines. Okay, be careful. You're only canceling the squared part here. There is still a sine x, which he knew. He just. So we wound up with sine x equals sine x, the right-hand side. Okay? Some of you may have noticed on the quiz last Friday, if you did not show a very clear sequence of steps, you got a little bit of points taken off, okay? You can't skip a bunch of steps. And if you write extra stuff and you don't need it, and it doesn't make sense, cross it off, okay? I know a couple people had stuff that they didn't use that didn't really work, and then they kind of had a mess. Okay, number 7. I think we've done this question before as well. Or, you know, well, actually we may have done this whole question before, but if we factor the top, how will that factor? Okay. And the other parenthesis will be? And do you want to do the trade at the same time for the denominator? These are strange ones that we haven't used much yet. We're going to use them a lot more in chapter 9. But cosine of 2x has how many different options to trade for it? 4? 3, okay? And which one do you want to pick? Okay, if you look at the 3 options, the first one is looking good. Why? Why would you pick that one? Because it's already one of the factors of the numerator?
Can you trade either one out? Like, because you got cosine x squared on top minus sine x, you just trade that for cosine 2x.
Yes, you could. Yep, absolutely. Sean said, could I have just realized that this was a cosine of 2x? And then left this one cosine of 2x and canceled. Yep, doesn't matter. All right. Otherwise, this quantity is going to cancel. And we're left with cosine squared plus sine squared, which we could trade for just a 1. Cosine squared plus sine squared. The most famous Pythagorean identity in trig. So we end up with 1 equals 1 or equals the right-hand side or whatever you want to write there. All right, one more of these, and this one is very tricky, guys. Will you look for something that says a cosine theta over 2? It is under half-angle relations. It's kind of like your half-baked relatives, right? Your half-angle relations. All right, what's different about this and this one up here?
That one's cosine squared.
Yes, this is cosine squared. So if we square this side, we would square this side. So the cosine squared of theta over 2, which does not square the theta over 2, it only squares the whole quantity, the whole function. When you square this side, do we need a plus or minus anymore? It doesn't matter what you square, positive or negative, it'll become positive. And the square root will go away, so we wind up with 1 plus cosine over 2. So that's the trade we're going to make for this. Sean, did you have another question?
There's no such thing as like full angle relationships, or like that would be a full.
The regular angle relationships are like sine equals 1 over cosine. These are just when you have an x over 2. All right, so we have 2 times this thing we're trading it for 1 plus cosine over 2 times a tangent. Now we could trade that tangent out, or we could leave it. It doesn't really matter. Okay, we'll leave it. Heard somebody suggest leaving it, and it does seem like there already is a tangent on this side, right? So maybe it'll be okay. It is multiplied, and this one on the right-hand side is added. But what happens with our algebra? A multiplied 2 and a divided 2 could just divide out, right? So then we have 1 plus cosine of theta times tangent theta. What's that making you think we maybe could try? When I see you could make it a sine over cosine if you want, but it's longer actually that way. If you distribute, you get the tangent plus a tangent times cosine. We want a tangent plus something, right? What do we want this to turn out to be? Somehow just to be a sine. What is tangent? So when we multiply by a cosine, we get the right-hand side from up here. Now, do you want me to talk about if I traded it to a sine and cosine, what would have happened here? Okay. If I would have traded this right here so that it said 1 plus cosine times sine over cosine. Okay. When I distributed it, I would have had sine over cosine plus, and this one times this, the cosines would have canceled, so I would have had sine. Now, before I can add those together, what do I need to do? Actually, I don't want to add them together. I don't want to get a common denominator. What is this right here? Sine over cosine is? So either way, it's about as long either way. I was thinking of a different problem. Okay, ready for the equation solving? All right. Directions say solve each of the following for values of x where x is from the domain indicated. We need to find all the values between 0 and 2 pi. So are we good? What are we not going to need? No plus or minus anything, okay? We just need however many answers occur. Could be 1, 2, 3, 4. All right? If we divide by 2, we get the sine is negative square root of 3 over 2. We go to the unit circle. And we look for where the sine is negative square root of 3 over 2. And what do we write down? Whoops, negative. And 5 pi over 3, that's it. We are just writing down, sorry, going the wrong way. There we go. Any answers between 0 and 2 pi. So 4 pi over 3 and 5 pi over 3. Guys, just to tie this to what you're used to talking about, a sine graph looks like this. We want to know where it hit negative square root of 3 over 2. And it did it twice, right over here. At 4 pi over 3 and 5 pi over 3. Does that make sense? Twice past pi, right? All right, number 10. How do you want to start that one? Add cosine? If you have a good idea, okay. Noah's idea was to add cosine over to the other side, and then we could divide a cosine off each side, okay? The problem is you will lose one solution. Anytime you divide by an x, you lose the possibility of a solution. Because, and I don't know that it would have made a difference on this question, Noah, but if we factor this out, okay, we have where is the cosine of x equal to 0, or the sine of x minus 1 equal to 0, which would become sine of x equals 1. The way you were talking about, you would just have the sine of x equals 1, which would have only one solution. And where the cosine is 0, I think is going to have two solutions. And actually, I'm not giving you the right number of solutions because it says we have to do all the way from what? Negative 2 pi to 2 pi. All right, I have an easier time picturing the graph. I'm going to do cosine first. Cosine looks like this. Here's 2 pi. And does the same thing on this side. So I need everywhere that it hits 0. Can you look at your unit circle for some hints what these ordered pairs are right here? Where's x 0 at? Pi over 2 and 3 pi over 2. So what do you think if we're going all the way to negative 2 pi? Negative pi over 2 and negative 3 pi over 2. Does the graph help you see the symmetry? Okay. So this has 4 solutions, plus or minus pi over 2 and plus or minus 3 pi over 2, or you can write them all out. Now, where is the sine equal to 1? Exactly 1. Okay, be careful. This one's not odd. Or it is odd, I'm sorry, not even. So here, if this is pi over 2. And where's the other place over here? Nope. Negative pi over 2 would be down here at negative 1. Negative 3 pi over 2, right. Brennan would be this other one. So this really only has solutions at pi over 2 and negative 3 pi over 2. But is that already covered here? So these are the 4 solutions that we would need.
Wait, why would the sine of x have, for 1, if it's just 1, it would only occur at a pi over 2.
The directions to this question, Sean, said everywhere from negative pi over 2 to pi over 2. So that means you have to be, if you're looking at your unit circle, you have to go once this way and once this way to give all the answers they want. Otherwise, it helps me to graph it to think about how many answers I need if I were to graph all the way from negative 2 pi to positive 2 pi. There are 2 places for sine, and there were 4 places that cosine hit 0. Anybody else have a question? All right, number 11 is pretty straight up, and it just wants answers from 0 to 2 pi. Can you guys try this one on your own? Anybody want to come up and put it on the board? Put some notes up there, talk about it, anything? After you added 3, what did you try? So you have the tangent squared is the square root of 3. Nobody's gonna stop me. It should be regular tan, you're absolutely right. And it should be plus or minus over here. Okay. Now, what am I looking for in an ordered pair if I want the tangent to be square root of 3? The ordered pair would have to have, so when I put the y over the x, I get square root of 3 over 1. But it could be plus or minus here or plus or minus here. So where is the tangent? Square root of 3. Okay. Now what were the directions to this question? All answers 0 to 2 pi. So what do we need and what do we not need? We don't need a plus or minus. How many solutions do we need? It says all the way from 0 to 2 pi. How many places, if it was plus or minus, there were how many? Right? 4 solutions worked. So we need to list all 4 of those. What were they again, guys? Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay? The tangent is square root of 3 2 places, okay? And the tangent is negative square root of 3 2 places. That's why we wound up with 4 answers. Does that make sense now? Okay, you don't necessarily need to write that down, but. All right. Number 12. What? Well, we could not do it if anyone would remember why we could not do it. We actually did it yesterday, but I'm going to do it again real fast. What can you take out? Okay, so we have where's the sine equal to 0? or square root of 2 cosine of x equal to 1. If I set that equal to 0, add the 1 over there, divide by square root of 2. What is 1 over square root of 2? Square root of 2 over 2. I go really fast, I know, but we did this exact problem yesterday on the front of worksheet 1, I think. All right, where's the sign 0? In radians from negative pi to positive pi. Or, I'm sorry, negative infinity to positive infinity. All real numbers, all real answers. What? Where's the sign 0? You're right. Pi, 2 pi, 0 pi, 3 pi, 5 pi, 4 pi, 7 pi, 9 pi. So you could write just plus or minus pi, or 0 plus or minus pi, or pi plus or minus pi, or 2 pi plus or minus pi. It doesn't matter. It's basically all the multiples of pi. Okay? Where's the cosine square root of 2 over 2? Pi over 4 and 7 pi over 4. Is there a shorter way to write that one? Yeah. Meaning you could go this way 45, or this way 45, or this way a pi over 4, or negative pi over 4, and you'd hit the 2 spots. And cosine repeats every 2 pi. Okay? All right. If you've been having a little nap, now is the time to wake up and pay attention, because this is a complicated question. It helps me to think about the graph. This is a sine function. Okay? Looks like this. We don't usually graph in degrees. It wants answers in degrees, but let's just hold off on that. Think about radians for a minute. What is the sine of 2x graph as? What's the period? Pi, which is equal to how many degrees? 180. So if we have to go out, please, to 360, it looks like this. Everybody good? Okay. How many times did that graph hit 1/2? Well, 1 is here, so 1/2 is somewhere in here. How many times did we hit 1/2? 4. Okay, so we should get how many answers? 4. It is very tricky for students to think about generating 4 answers to this kind of question. So what I would like you to do is think about it as being a negative infinity to infinity question in degrees first, and then we'll find the 4 answers. We're going to do a U substitution like we did yesterday. Okay, so in degrees, where is the sign 1/2? If we look at the unit circle, the sign is 1/2. How many degrees, remember guys? 30 and, that was negative, sorry, I circled the wrong one. 30 and 150. Everybody with me? And it would repeat every, on the unit circle, 2 pi, but we're in degrees. Okay. But what is U? U is 2x. So now we're done with this thinking this way. We want all the answers between 0 and 360. Okay, first of all, let's divide everything by 2. So x is 30 divided by 2, anybody? 15, and plus or minus 360n divided by 2? Okay, and this one, 2x equals 150. All right, now we're down to, I want only the answers between 0 and 360. So what's one of them? 15 is right here. The next one? 75. That one's right here. But what's this next one? You got to add 180 to this one and you get, okay, and add 180 to 75 and you get, does it kind of make sense, even if it would be a difficult question for you to do on your own at this point? Okay. This is telling you that it completes 2 periods between 0 and 360. So where the sine was 1/2, twice between 0 and 2 pi at a normal cycle, okay, when we've changed it to a period of pi, or in this case 180, it's going to have 4 answers before it hits 1/2. And we don't want to add 360 to find those, because that'll put us outside of the range where we need to be. All right. Is that the last one?
Yeah.
Okay. We still have time for some questions on 8.1? Sorry, 8.1. Yes. Great questions both. Okay. I would like to do numbers 2 and 10, and then we'll see if we have more time for more questions. Number 2 is very tricky. Guys. Number 2 is very tricky because you have to find the period that it repeats in. I'm going to graph this. 5 sine 3x. What mode should I be in? What mode should I be in, guys? Yeah, it does not say degrees anywhere, so we have to answer in radians. When you get to number, 19, it switches over and says it wants degree answers. All right, so I've typed all that gobbledygook in, and then it wants to know when it's going to hit 1. I am in radians, so I'm going to do a zoom trig and see if I can spot the intersection points. Otherwise, I may have to adjust my window. Unfortunately, there are a lot of intersection points in this window. Okay. It might be beneficial if we stretch this out a little bit. I'm not going to. I'm going to let you guys, because I'm thinking this is what you saw, so I'm going to leave it like this. But the 2 intersection points closest to the origin are right there and right there. Does everybody see those? Okay. And I'm going to need to figure out how far until it starts to repeat, so I'm also going to need to find that ordered pair, or that point. I know what the y values are. What are all the y values on that line? 1. Okay. But we need those 3 x values. Okay. So somebody find me the first one. You already got it, anybody? What is it? Negative. It should be negative, right? The first one?
-2.49.
The second one's 0.712.
Okay, the first one is not negative 2 point anything.
0.249.
Okay, 0.249?
Yeah.
Okay. The next one is, okay. And did anybody go over and find this third one yet? Okay. Everybody clear that those are the 3 points right here? All right, these are the 2 answers closest to the origin, and then they start to repeat, and this is where the next answer is. What we want to know is how far is it from here to here? So I want you to think about this. From negative 0.249 to 0 is how far? 0.249. And then from 0 on to 1.845 is 1.845. And if I add those together, okay. Does anybody know? You can put plus or minus 2.094 n on the back of those. Did anybody figure out what that is? Look up here, guys. What do both of these have for a period? 2 pi over 3. If you type 2 pi divided by 3, you get 2.094, okay? Sorry, I wasn't watching the time. Yeah, I'll do 10 tomorrow. I'm here tomorrow. We do need to go through 8.2 quickly tomorrow, and it is a lesson that takes a little while. So, but I'll try to find time to do at least 10.
I could not find